Alright, so let's look at V1, exponents with integer bases. So basically our instructions are to evaluate, meaning we should come up with a single answer when we get done. Start with number 1. So we've got 2 as our base raised to the third power as our exponent. We know that means 2 multiplied by 2 multiplied by 2. 2 times 4 is, 2 times 2 is 4, 4 times 2 is 8. Sometimes my mouth goes a little bit slower than my brain. Alright, number 2, we've got 10 raised to the second power, meaning 10 times 10. Well, 10 times 10 is 100. Number 3 is 3 to the third power, or 3 cubed. You know that means 3 multiplied by 3 multiplied by 3. Well, 3 times 3 is 9. 9 times 3 is 27. Number 4 is 9 raised to some power gives us 1. Now, excuse me, if we remember from our notes, we talked about if we had a base raised to a particular power, it always equaled 1. So hopefully you remember that any number raised to the 0 power is 1. So your answer for V would be 0. And I'm going to make a note. Any number raised to the 0 power equals 1. That should be in your notes that you have. Number 5 says 10 raised to what power equals 100? Well, you got to think, okay, what do I have to, or how many times do I have to multiply 10 by itself to get to 100? Or how many times do I have to double, triple, quadruple 10 to get to 100? Well, we know that 10 raised to the second power would be 100. We have number 6. That's 10 raised to the r power equals 100,000. So you would think, how many times do I have to multiply 10 by itself, or how many 10s do I need to make 100,000? Well, we know 10 to the second power is 100, 10 to the third power is 1,000, 10 to the fourth power is 10,000, so 10 to the fifth power, so r would be 5. Let's look at number 7. We have 10 to the c power equals 1. We'll look at our note here. Any number raised to the 0 power would be 1. Let's look at number 8. 7d, or 7 raised to the d power equals 1. Doesn't matter if whatever this number is, whatever the base is, if it's raised to the 0 power, it will always equal 1. So d would be 0. For number 9, it says -1, and we want to raise that to the fourth power. Now really think about that. That means I'm going to take -1, multiply it by -1, multiply it by -1, multiply it by -1. So -1 times -1 is +1. +1 times -1 is -1. -1 times -1 is +1. So one of the things that you can think of, if you have a negative number raised to an even power, the product will be even. And that may save you some time when you're trying to multiply them. So our answer would be 1. Let's look at 10. We have -2 raised to the 1 power. So if you think about this right here, It's not being raised to an even power, so my answer is not going to be even. It's being raised to an odd power. So my answer is going to be odd. So negative 2 to the first power is just negative 2. So we could write that note there. If you have a negative number raised to an odd power, the product will be odd. So odd and odd, even and even. So we've got number 11. Let's scoop this up. We've got 10 raised to the p power is equal to 10. Well, how many times would I have to repeat 10 to get 10? Only once. So p would equal 1. And let's go ahead and evaluate number 12. We've got negative 4 raised to the third power. So we have a negative, and it's raised to an odd power, so that means that our answer has to be odd. So we've got negative 4 multiplied by negative 4 multiplied by negative 4. So 4 times 4 is 16, times another 4 is 64, and it is odd. So then, let's go with number 13 here. 2 raised to the s power equals 64. So what number would I have to raise, or how many times would I have to repeat 2 to get to 64? Well, let's kind of break this down. If I did 2 times 2, that gives me 4, times 2, that gives me 8, times 2, that gives me 16, times another 2, that gives me 32, times another 2, that gives me 64. So S would have to be 1, 2, 3, 4, 5, 6. So I'd have to take 2 and raise it to the 6th power to get 64. Now if you notice, I could have taken 64 and I could have just divided by, I'm going to show you. If you ever get stuck on what you need to do, take 64, divide by 2, because that's our base, and we get 32. Take that 32, divide by 2, and you get 16. Take that 16, divide by 2, and you get 8. Take that 8, divide by 2, and you get 4. Take that, divide by 2, and you get 2. All right, so let's count. 1, 2, 3, 4, 5. Wait. 1, 2, 3, 4, 5, and then I take my 2 and divide it by 2, and I get 1, because that's where I'm trying to get down to. How many times do I have to divide my product here by my base to get to 1? So it was 64 divided by 2 gave me 32. Then I took 32 and I divided it by 2, and it gave me 16. I took 16 and I divided by 2, and I got 8. And I then took 8 and divided by 2, and I got 4. Then I took 4 and divided by 2, and I got 2. And then I finally took 2 and divided it by 2, and I got 1. So even if you count the loops, 1, 2, 3, 4, 5, 6. All right, I think I'm going to call it quits there. Hopefully this was helpful, and I will be back with you on the next video. Bye-bye. Well, I'm going to pull this over before I say bye-bye so you can see what I did. I didn't realize you couldn't see it. There we go. That's what I did. See you on the next video.